2019 was a very interesting year for my family. We moved, I'm going to a new school, and we had a baby who is currently sleeping upstairs, so he won't be in at least this part of the video. That said, for paleontology, 2019 was also very interesting, with a plethora of finds that will probably make this my longest video yet. And so with that in mind, let's get started. For me personally, this year had a lot of finds in a field that I am very much invested in, and that's the origin of dinosaurs. A lot of species that are either very early dinosaurs or very closely related to the dinosaurs were all described in the past year. And understanding how these different species evolved and developed and became successful can help us understand what happened after the Permian-Triassic and Triassic-Jurassic extinctions, and potentially help us understand how life might adapt to our modern-day extinctions. Outside of the dinosaurs, there were things called dinosauromorphs, meaning that they were towards the lineage that would lead to dinosaurs, but weren't quite there yet. Gnathovorax was found in Colorado, and it helps show the diversity of one of these groups of dinosauromorphs, the Silosaurs. It shows somewhat omnivorous teeth, which is a unique adaptation among the Silosaurs, which have either been carnivorous or herbivorous. What it shows is potentially the Silosaurs were adapting towards herbivory based on competition from related animals in the dinosaurs, such as Coelophysis, which was very much a carnivore. This omnivory or herbivory could have been outcompeted by other dinosaurs then in the future, such as the prosauropods and ornithischians, the latter of which isn't as common in the Triassic sediments, but did evolve during this time period. As for the prosauropods, many of them were from the southern continents, meaning their eventual migration northward could have outcompeted these Silosaurs, which had previously filled the niches of herbivores. One of the earliest known dinosaurs is Herrerasaurus, which was almost a theropod. The reason I say almost is because a new study has shown with a close relative of it, Gnathovorax, that they weren't actually theropods. In fact, they weren't even prosauropods as some people have suggested. Herrerasaurs, being so early in the dinosaur lineage, have been bounced around a lot as they don't have a lot of the more derived adaptations that could help narrow down where exactly they belong in the dinosaur family tree. This is what makes Gnathovorax so unique. Gnathovorax shows a series of traits which show that it isn't aligned with either the prosauropods or the theropods, or even not being a dinosaur but an early ancestor of them, as some studies have suggested. Rather, they are dinosaurs and in Saurischia, which means they're related to the prosauropods and the theropods, but they aren't either of those. They are their own independent group. Gnathovorax, in combination with some of the other dinosaurs I'm about to describe, can show just how diverse the very early dinosaurs and very early meat-eating dinosaurs actually were, and just how unique it is that only the theropod lineage survived into what we modern day know as the most dominant predators of the Jurassic and Cretaceous. Still coming from the Triassic, but this time of Europe, we have Notatesseraeraptor, which was found to have similarities to the Coelophysids and Allosauroids. What it shows is that the Allosauroids were a separate clade from the Coelophysids. Some people had suggested that the Allosauroids had evolved out of the Coelophysids, and so they were very much related to the Coelophysids. Notatesseraeraptor's combination of these traits shows that they had evolved independently, and they weren't necessarily nestled right within one another. This helps to show just how broad and diverse the dinosaurs were, especially the early theropods. And this is very important as we move into our next subject. Coming from the Middle Jurassic, Asphaltovenator is one of the best dinosaurs for helping us understand just how the diversity of theropods came about. While I did mention that they were very diverse during the early Jurassic and late Triassic in the past articles, this one shows just how similar the later, more dominant theropods were. Before the finding of Asphaltovenator, it was thought that the Allosauroids and the Sauropods, which would lead to animals like T-Rex, but also the birds, were very closely related, and that the Megalosaurs were essentially an outgroup to this, where they had a similar ancestor, but before the same ancestor of the Allosauroids and the Sauropods. What makes Asphaltovenator so unique is a combination of traits that resemble both the Allosauroids and the Megalosauroids, and this includes things like some small fenestra, or holes in the skull, that are more closed off in the Megalosauroids, but also having small depressions near the nose that is more reminiscent of the Allosauroid condition. While Asphaltovenator is probably more closely related to the Allosauroids, What it has done is shake up our understanding of the dinosaur family tree in the theropods. Instead of things like the Spinosaurs being within the Megalosaurs, they seem to be their own independent clade that evolved from what was originally Carnosauria, which now includes everything from the Spinosaurs to the Allosauroids and Carcharodontosaurs. Effectively, as the graphic shows you, there has been a large mix-up based solely on this one species being found, and other researchers have entered asphaltovenator's information into their own data sets and have found similar things. So it's very promising that asphaltovenator will revolutionize our understanding of the theropod dinosaur tree. As for what relevance that has for the average person, can be debated, but understanding these evolution patterns can help us understand just how life diversified throughout the Mesozoic, which was a long period over hundreds of millions of years. And understanding that can help us understand potentially how we got where we are today. Further down the Allosauroid line, there were the Carcharodontosaurs, which were most often seen as dominant predators in their environment, such as with Gnathovorax in Patagonia of Argentina. But we can at least identify now that the line that would have eventually led to Gnathovorax probably wasn't as large as Gnathovorax. Lehosvenator has been shown to be an early Carcharodontosaur, found this year in Argentina, and much smaller than the massive Gnathosaurus or its relative Mapusaurus, also from Argentina. What it shows is that the early Carcharodontosaurs were actually rather small and diminutive, and definitely weren't the kinds of apex predators that you would have expected of the group based on what we had found previously. But this isn't the only small Carcharodontosaur that was announced this year. Another coming from Thailand was also announced. Simbakubwa, announced this year, has been shown to be one of the most primitive of the Carcharodontosaurs, which is unique for two reasons. One, it's still in the Cretaceous, so it still shows that either they were a very late adapting clade of dinosaurs, or it was very unique in lasting that long as still being very primitive, and not being subject to as much evolutionary pressure as some of the other Carcharodontosaurs that have been found. The other reason it's unique is, as one of the most primitive of the clade, it wasn't found in somewhere that we're used to finding Carcharodontosaurs. Generally, they've been found in parts of Africa and South America. Simbakubwa's strange locational find in Thailand just shows how much more fossil work needs to be done in these more remote regions of the world, as there's a lot of very important fossils that might be found from there, including a few more from Thailand. Fuangvenator has been shown to be a new species of Megaraptorian, also coming from Thailand. And the Megaraptorians are interesting because no one's exactly sure where they lie on the dinosaur family tree. They may be closer to things like the Tyrannosaurs, or even potentially very primitive Tyrannosauroids, meaning they would have been very closely related to some of the first Tyrannosaurs, such as Dilong coming from China. There's also the chance that they could have potentially been more closely related to the Carcharodontosaurs and the Allosauroids. The main issue with this is that they are very fragmentary when they've been found. Fuangvenator is very similar in that it was also very fragmentary, which is unfortunate. However, it does help us understand a better idea of just how diverse and spread out these species were, as previously they haven't been found in too many locations. Understanding where exactly they may have originated from may help us understand where exactly they evolved from. And for this we will need more study, as again, they are very fragmentary generally, but I'm hoping that we will understand where they come from, because they're the most interesting clade of theropods, to me at least. From the same paper was Raptor, a very early Saurosaurian. And this may potentially lead to the idea that even Fuangvenator was an early Saurosaur, such as the Tyrannosaurs were. Raptor, combined with Fuangvenator, helps to show again that the Megaraptorians may be Saurosaurs, but it's still hard to tell. These two new species, though, are very unique, and so hopefully there will be more work done in these Cretaceous sediments of Thailand, which have seemingly only recently been studied, and so will hopefully hold all new treasures for paleontologists to study. It's important to also understand that likely all of the Saurosaurian dinosaurs were feathered, and new finds coming from Australia likely indicate that they had at least made it there too. While there haven't been any bones found with feathers, there have been isolated feathers found in certain sediments coming from Australia. During the Cretaceous, when these sediments are from, Australia would have been very close to the North Pole and likely would have experienced a few months of total darkness each year. What this could potentially mean is that feathers were actually used for warmth, which has been hypothesized by many researchers in the past. However, not all of these feathers would have been just for warmth, as some of them were the asymmetrical type flight feathers that you might expect from modern day birds. So while yes, it does seem like this could have been the potential cause, warmth, for the evolution of feathers, by the time we have them in cold environments, they're already starting to fly, which means there needs to be a lot more study done on the origin of feathers, and hopefully more sites found, because there should be more sites from even the Jurassic or beforehand, which could help illuminate the origin of feathers. With the origin of feathers being mentioned, it's important to bring up the oldest feathers known, from Cynodont from the late Jurassic. That was until a new paper showed that the sediments were actually from the middle Jurassic, meaning that the sediments that they were from and the feathers then were even older than previously thought. What makes Cynodont unique is that it's not very closely related to the dinosaurs that are more normally found with feathers, which is the theropods. Rather, it was an ornithischian, or herbivorous dinosaur, more closely related to things like iguanodon or triceratops. With this very unique find being pushed even further back, what it could mean is that the common ancestor of the ornithischians and the theropod dinosaurs may have already evolved feathers and passed them down to both of these different clades. While this common ancestry doesn't mean that all dinosaurs likely had feathers, what it does mean is there's a good chance that quite a few of them did. And this would very much change the public's perception, at least, on just what the dinosaurs looked like, as quite a few people are still very bitter about the idea of feathered dinosaurs. Unfortunately, the only living dinosaurs that we can do anything with for today are the birds. And that leads into how do the dinosaurs go extinct at the end of the Cretaceous? Many people have suggested that the impact in Chicxulub was what killed off the non-avian dinosaurs. And there's been some debate about that, such as the Deccan traps coming from India, which were erupting about the same time and were massive volcanoes, which have led to extinctions in the past, as I will talk about for the Permian-Triassic extinction in just a few minutes. A new study suggests that it likely wasn't the Deccan traps, though. And this is because more specific radiometric dating for the ages of the Deccan traps suggests that they had erupted at most a few thousand years before the first impact, and then the next 3 series of eruptions from the Deccan traps occurred after the impact. And that's at best. The error involved in the first measurement could mean that that first eruption even still occurred after the impact at Chicxulub, meaning that the Deccan traps may not have had as significant of an impact on the dinosaurs' extinction as some people may have previously thought. This research seems to agree with that of another paper, which, while it wasn't looking at the Deccan traps, was instead looking at the environmental changes that were happening in North America in the few millions and thousands of years leading up to the extinction. What the study suggests is that environments in North America weren't changing very severely during the end Cretaceous, and so animals like Tyrannosaurus rex, which lived during that time, wouldn't need to change their food sources or behaviors or be subject to much evolutionary pressure simply because the environments were very stable. It was just a sudden impact that changed those environments that may have caused the extinction. And with that in mind, we need to get into a very controversial paper, not necessarily because of the content of the paper, but because of how it was reported. Normally when a paper comes out, it has full time to be peer-reviewed and reviewed by other researchers before it's commented on by the media. Unfortunately for this paper, the lead author of it decided to leak to the news media early what it contained. And the news media made some very bold claims about what the researcher said. Because of this, it was already seen in a bad light when it came out, and it highlights just how important it is to have a proper peer review without the media trying to interrupt the research in favor of a quick buck. In fairness, the paper does make some bold claims, which will need to be verified by other researchers, but the bad taste from the media already kind of dampened the feel of it for many other researchers. What the paper suggests is that they have found a site that shows what happened immediately after the impact that may have killed the dinosaurs. What they report is a potential siege, which is a shifting of water back and forth due to something like an earthquake, which, considering the impact would have been a mountain about the size of Mount Everest hitting the planet at 50 kilometers an hour, probably would have caused a few earthquakes. The siege that they report would have pushed a series of logs and very large fish, very similar to sturgeon, up onto a beach. This then, as it drained, would have lined them all up, as is found in their reported fossils, and then the backwash of that siege coming back would have buried these trees and the fish. There even appears to be an ammonite in the sediments, which is a marine species, which wouldn't be likely found around the freshwater species of fish and the trees that were found as well. What this could mean is that the siege was in something like a bay, which transitioned from salt to freshwater, and that the ammonite was pushed in alongside all of the rest of these fish. Another issue with the paper is that all of the research took place on private land, which, while it is great to be able to use private land for research, it does mean it's harder for other researchers to get in and do their own independent studies. There is one site where there are sediments that are definitely from the impact, and that's the crater. A number of core samples were taken from the crater this past year, and what they show is actually rather what you would expect. The first few layers of rock show giant cracks and fractures, which is what you would expect when they are getting hit by a rock from outer space at a few thousand miles per hour. Above this, there are large chunks of molten rock, meaning that these would have been melted by the impact and then landed back within the crater space. On top of that, there are sediments that were brought in because the impact was on the ocean and would have pushed the water out, and that water would have brought sediments back in as it came in and filled. However, some of that water would have still made it onto land, and what it brought with it is charcoal. What this means was that the impact likely started massive wildfires, at least in the northern hemisphere and the nearby impact zones. One potential reason for these fires being as bad as they were is the vaporization of sulfur-containing compounds. The interesting thing about all of these layers is that they didn't contain sulfur. The sediments surrounding the crater actually do contain sulfur, and this is important, as it means what would have been in the crater likely also did. But since it's not there, it's much more likely that the impact vaporized this sulfur and would have sent it into the atmosphere. Sulfur is very good at blocking out the sun's rays, and could have potentially caused a global winter, where temperatures would have been near freezing for quite a few years, anywhere as long as a few decades to a few thousand years, depending on what research is being looked at. Fundamentally, though, it does show that the impact had a very significant impact on the environment surrounding the crater, at least. And these kinds of impacts shouldn't be overlooked, especially in the mammals. There's been a new fossil find in Colorado containing a multitude of mammal fossils immediately after the Kpg extinction. What this means is it shows a very good record of how mammals were able to evolve and adapt after the extinction and fill as many of the niches as they do today. The very first mammals that are found here had very flat and broad teeth, likely used for crushing nuts and seeds. However, as time progressed, they became more and more cusped teeth, meaning that they would have been used more for eating different types of plant material that was softer and not as specifically for eating nuts and seeds. By the time larger animals show up with more diverse and cusped teeth, we have the addition of things like beans and legumes into the environment. These larger animals still wouldn't have been absolutely massive, on the order of about 80 pounds or 35 kilograms. But they were significantly larger than the very small animals that did survive the extinction. And the reason that the beans are important is because beans contain much more protein than a lot of the other plants that would have been found in the area beforehand. What this shows is just how dependent on plant life the mammals actually were, and that it's not necessarily just down to them being able to repopulate the land, but also the plants repopulating the land first. After the extinction, there was also a broad diversification of the mammals, including groups that aren't alive today, such as the hyaenodonts, which were dominant predators in many environments. A new species of hyaenodont, Simbakubwa, helps to show that they radiated out of Africa first, and that they were very much dominant, being potentially as large as a polar bear despite not living anywhere near the polar regions, where larger body size is more of an advantage. What the researchers did to get their range of estimates is measure the fragmentary skull of Simbakubwa and apply the same body plan that would be found in something like one of the big cats, like a tiger or a lion. The problem with this is the hyaenodonts weren't built the same way as tigers or lions. Rather, they had a much larger head comparatively to their body. So this measurement that makes it potentially the largest mammalian predator of all time is somewhat suspect, and a much more conservative estimate should be considered a more accurate representation. But even for time periods before the Kpg extinction, there's been a lot of study on mammals, and one of them suggests that the reason that many early mammal relatives were nocturnal is something to do with anatomy. Well, many researchers have essentially left it at they were nocturnal because the dinosaurs were out during the day and would have predated on them. Some researchers wanted to look more specifically than that, and the answer they landed on had to do with the animals being able to reproduce. Specifically, certain parts of the male's anatomy wouldn't be able to handle the heat of the midday sun during the Triassic or Jurassic in combination with internal body parts. Essentially, the higher temperatures of the Triassic and Jurassic would have overheated some of the early mammals and caused them to become infertile. This then would have selected for animals that were more adapted for going out at night during cooler temperatures, at least until the body was able to evolve to a point where it could keep itself cool, at which point, yes, they could go out in the sun. As for how the mammals were able to become successful in small niches, a new study of very closely related animals, the Tritylantodons, helps to show what they were able to do in order to succeed. The Tritylantodons had teeth with varying cusps, which helps to show that they had a very diverse diet. Additionally, their teeth also shows forms of microwear, likely coming from either hard seeds that were being eaten, potentially insect carapaces, or even if they were eating something like worms, pieces of dirt and gravel that would have been caught in the teeth and worn down into them. For the mammals, this means that they were able to succeed because they had a very diverse diet. They weren't specialists focusing on one singular food item, but rather had a broad diet that was able to encompass many different foodstuffs. So in times of hardship, they were able to succeed where other species might not. This past year, there was also a study on the origins of teeth, and there's been multiple ideas for this. The first idea is that teeth evolved from the outside in, meaning there was some kind of scale in an early fish that then moved into the mouth and hardened into the teeth we have today. The other idea is that they were part of the gills and would have moved into the mouth in order to help swallow prey and then hardened into the teeth that we know today. What this study suggests is that they actually did come from the outside in, being scales originally. What has indicated this was a cross-section of the skull of an amphibian, which shows what the researchers call dental flooding. The early amphibians had what are called palate teeth, which were teeth on the palate. What the cross-sections showed is that these palate teeth would become overgrown by other layers of bone, and within these new layers of bone would be additional teeth, meaning that each new layer of bone would have contained teeth. A study of certain groups of older fish shows that this is the same pattern in which some scales would grow. And so it's very likely that the first teeth evolved from these different kinds of scales moving into the mouth and regrowing over each other in order to maintain a grip on prey, and eventually evolved into teeth. Remaining in teeth, we're going to look at an animal whose name literally means big tooth, and that's Carcharodontosaurus or Ototus Megalodon. There was a study early this year that reassigned the genus of Megalodon. Originally, it was thought to be a Carcharodontosaurus Megalodon, or a Carcharodon Megalodon, very closely related to things like the great white shark. However, this new study suggests that it's actually more closely related to the genus Ototus. What this means is that it likely wasn't as closely related to things like the great white shark as previously thought. However, the great white shark still had a major impact on its evolution. A new study on exactly when Megalodon went extinct finds that it may have gone extinct as much as 1 million years before previously thought. Many teeth from the younger time period weren't very accurately dated, and this study was able to show that, and actually coincides the extinction of Megalodon with the rise of the modern great white. This is likely because the great white outcompeted small, young Megalodon. Not the adult Megalodon, which definitely could still take out whales, but rather the small ones that should have also been hunting the same food sources, such as seals. Because the great white was able to outcompete the young Megalodon, not enough of them were able to reach adult age and continue breeding, and that would have eventually led to their extinction. This shows how, even though something seems like an absolute dominant predator in its environment, which Megalodon was, small changes in even smaller predators can still outcompete them in certain niches and cause the extinction of an entire species. As for Megalodon's size, it also saw a slight reduction, from about 60 feet to about 50 feet, which is 18 meters to 15 meters. The reason this happened is because a researcher took a better look at teeth from very specific parts of the mouth. Previous studies had used teeth from essentially all parts of the mouth to try and estimate the size of Megalodon. This researcher decided to choose to use teeth from more of the central parts of the mouth in order to try and get a better idea of just how big it might have been. This new estimate does seem still very large and is very reasonable, but it's not quite the behemoth that many other people would have wished it would have been. It's still massive though. You can calm down if you're concerned about it getting slightly smaller. That said, if you're looking for something much larger than 15 meters, you don't need to look much further than the sauropods. And while some of these aren't quite 15 meters, they are still very large animals that are very unique. Bajadasaurus was a genus of sauropod very closely related to Amargasaurus, most commonly depicted with either a frill or long spines coming out of the neck. Most recent research has assumed that it has been spikes rather than a frill, but occasionally reconstructions or representations are still shown with a frill, such as in Pokemon. In Bajadasaurus, only one vertebra with a spine was found, but that spine was very severely tilted forward, something not seen in Amargasaurus. The author suggested that this was used essentially as a defense mechanism, where theropods and predators want to be able to try and bite on the neck because of these large spines. Unfortunately though, these spines would have been likely very fragile, and there hasn't been very in-depth study on the sediments the fossil was found from either, which may have deformed the fossil after it was buried and changed the shape of the original spine. As for the early sauropods, there were a lot of collections that may seem to be new species, and one of those is the genus Ngwevu. The fossil, now known as Ngwevu, was originally known as Massospondylus, and it was thought to be just another specimen of that species. However, a new study has shown that it is an independent genus, and it does deserve its own name, Ngwevu. Coming from South Africa, where there are a plethora of other early sauropods, such as Massospondylus, but also Ledumahadi and others, it helps to show just how broad and diverse the early sauropods were in South Africa and the southern continents, with even things like Buriolestes coming from South America. It also highlights the need to go through older collections and identify what may potentially be new species from stuff that was essentially cast aside because the researchers at the time thought they already knew everything about it. Hi everyone, thanks for watching part 1 of my year in review. We did launch a Patreon recently, so you can go check that out below. We also have started to set up our own website, which will have different paleontology blog posts and hopefully keep updated on a weekly basis of some of the new finds, which I won't necessarily keep all of those in my monthly review videos, but there's just extra information for you. Anyway, be safe, take care, don't go extinct.